Our next speaker is Dr. Lizwe Mdakane. He will be presenting on Spaceborne synthetic aperture radar for operational monitoring of South African oceans, oil slicks, and vessel tracking. Lizwe has multidisciplinary qualifications in science, including a BSc in computational physics, an honors in applied physics from UKZN, as well as an MSc in computer science, and a PhD in electronics from the University of Pretoria. His research interests are in the development of special information systems, artificial intelligence, image processing, data science, machine learning, particularly computer vision. Lizwe is a senior researcher focusing on improved understanding, management, and monitoring of maritime activities. His notable projects include the National Oceans and Coasts Information Systems, as well as the marine and coastal operations for Southern Africa. Remember, I said let's think a little bit broader than South Africa and see what we can do for the African continent and the region as well. His current projects include phase 2 of Mako South, which consolidates and extends collaboration, implementation, and services regionally into the Western Indian Ocean. Welcome, Lizwe.
Thank you, everyone. Thank you, Chair, for the warm welcome. So in the interest of time, I'll try to be quick with this presentation. So just a fun fact, South Africa actually has more ocean than it has land. It has 1.5 squares of EEZ size and only 1.2. And it is proposed to actually extend even more. So in my presentation, I'll be mainly talking about the role of operational Pakisa, also the National Oceans and Coastal Information Management System, integrated vessel tracking tool, the research and everything that I'm doing, and also final remarks and the vision of the decision support tool. So Operation Pakisa was initiated in 2014, if I'm not mistaken, to unlock South Africa's potential economic potential. So it was looking at marine transport and manufacturing, offshore oil and gas. So it was also estimated that our economy through the ocean can grow up until 177 billion rand to GDP. The ocean can create up to 1 million jobs by 2033 and also 7 billion investments. Also, Operation Pakisa is also important for marine protection and conservation of nature. In South Africa, we have almost 42 conservation areas that need to be protected over the oceans. So how do we do this? Through Operation Pakisa, National Oceans and Coast was initiated in order to provide the South African government effective governance over the ocean areas. The way this was done is that everyone was involved. We involved all departments involved, including Department of Environmental Affairs, Fisheries, the Navy, all of the clusters during the initiation process. So no one was left behind. So it was never a design that we say, here's the solution, use it. We went to the stakeholders, we said, what do you need? How can we build this? So it was a core development process where we had quarterly and annual meetings where we'll design models, get back to them, is this useful? Then they will also provide data to us. So it was co-benefiting everyone. From OCIMS project, we have several decision support tools. These include marine spatial planning, coastal flood hazard, marine domain awareness, which looks at the security, fisheries and aquaculture, water quality, sea state, which is also forms under sea rescue services, and also we're looking also at marine predators. In my presentation, I'll be focusing on marine domain awareness. Under this theme, we have integrated vessel tracking tool. So this tool's purpose is to improve the control and surveillance of vessels within South Africa, is to enhance coordination of enforcements where multiple departments can work together, including SAMSA, SANSA, the Navy, everyone work together using the one tool. We also identify and protect sensitive unique areas, as I've mentioned before with the marine protect areas. We also manage the limited human resources and the financial resources that will be required if everyone is working alone. We're also looking to address high levels of illegal fishing. So these are normally illegal, unreported, and unregulated, also known as IUUs. So on this slide, it shows an example of the web tool that we are using right now. I'm not sure if this is clear. So on the tool, we ingest a lot of data, multiple data. Example, these are all ships of different categories. It includes tankers, fishing vessels, all types of vessels that you can think about. You can also get the track of the vessel. That means you know where its history is coming from before it gets to South Africa. We're also ingesting space data, which is what the theme is about. For us here, we're using synthetic aperture radar to detect vessels. And this outlines the images, how they overlap. So some of the tools that are used to make decisions, we use AIS, which shows real-time positions of all vessels within South Africa. As mentioned, you can also inquire about the history of each vessel. You can also monitor different events. For example, you can schedule an event saying, let me know when vessel X arrives in South Africa. Another example, we also do data analytics, where we have heat maps to show all of the tracks that vessels normally take. As for example, tankers have a distinct route that they take when they come around the country. We also have a time machine capability when you can look at the past. If you want to see what were the vessel positions in 2018, for example. Okay, on the flow of IVT data, so we're looking at oil and water, which are the oil spills or bilge dumps. We're mainly using open data for this, which is Sentinel-1 provided by ESA. We also do vessel detection on the same SAR images. We also use AIS data provided by SAMSA. We also ingest VMS data provided by Department of Fisheries. So all of this data is combined to be viewed on one platform. Speaking of space, so my research mainly focuses on SAR images. So I'm looking mainly on bilge dumps, which is the oil and water, and vessel detection. So we use synthetic aperture radar because it's an active sensor. So that means it provides its own energy to measure the Earth. So it's not affected by clouds. It can work during day or night. And it's also independent of atmospheric conditions. The way you detect oil and water, you use the backscatter mechanism where the returned energy to the sensor when there's in the presence of oil spill is less, then this is shown as a dark region. And when the backscatter energy, when it detects a vessel, is higher, then you see a brighter energy. So a vessel then will show up as a bright spot. Oil and water will show up as this dark linear path as the vessel is dumping the oil. So for an operational system, we need certain requirements that need to be met for any kind of data sets. So for SAR, we determined that we need at least 90% of the EZ to be covered every week. This is just the minimum requirement. We can do better, depending on the chankuras. The SAR needs, the data needs to be taskable. So this is mainly for, if we are tracking a certain vessel, you need to be able to point the satellite, say, I need an image there, not wait for the revisit to happen. Normally what happens with the open data sources. And we need to be able to detect at least 50 meters of data or longer, of vessel, or longer. This is a good compromise between catching the big fishing vessels. And also we need multiple frequencies. Normally C-band or X-band is recommended for the oceans. Also the acquisition time, which means from the time the image is acquired to getting to the system, needs to be minimal, at least 30 minutes. Also, this is difficult with open data because it has to go through their own data centers. They process it, then they release it. Recommendations that we found is that you need at least 400 kilometers of swath, a 40-meter spatial resolution, or a 3-day or less temporal resolution is kind of the compromise that we can get to. So an example of the system, on your left-hand side, on this side, it's a map of the system showing all of the SAR images that have been downloaded for 1 month. So as you can see that we are processing all of these data sets, and all of these white points represent vessels. And then on your right-hand side is the AIS data. So this is the data where the ship sends their location. Then this is the data where we catch the vessels. So that's a big difference. So these are called dark targets. So the use of this is that when the ship decides not to send its location, with the SAR, we can still see the vessel. So the impact of this is quite high because in 2020, we ran analysis, where are these dark targets normally happening? And we found that majority of them happen on the edge of our EZ. So this may be a sign that there may be possible IUUs happening in these areas. We are not sure. But all we know is that there's a lot of vessels at the edge of South Africa that are not transmitting their location. The use of SAR for oil spill, this always goes on the news whenever it happens, when there's a big oil spill problem. This one is the one that happened in Brazil, which is kind of our neighbor. And that vessel, when it spilled, it was actually heading towards South Africa. So with SAR, when you detect these vessels early, you can actually detect that something is coming, because oil spill, depending on the size and the oil that is used, it moves with the ocean. So research on this, so all of our algorithms are developed in-house in CSIR. We have over 20 publications on this, and we use mainly machine learning, image processing software, mostly open source. The impact we've had with the system is quite huge. We've had impact on environment impact, where we're detecting oil spills in South Africa. We've detected illegal activities where we're helping the security cluster. We have economic impact where we are finding illegal fishing. These are some of the articles that I could find online. So to almost finalize this, the final remarks is that spatial and temporal coverage is very much important for operationally monitor anything using satellite. And what we found that open open data alone cannot do this. So a hybrid system is needed, where you use the open data and also commercial data to cover some of the weaknesses. So this is our vision. I will skip on this. So I would also like to present our marine and coastal operations for Southern Africa and Indian Ocean, supported by the Global Monitoring and Environment and Security in Africa, which is GMS in Africa. So this is an extension beyond South Africa. So we're looking at the SADC region and the Indian Oceans, as we know that you cannot protect your country not knowing what's happening in your neighbor's door. So in this project, we're working with 12 partners from 8 countries. So the system is extended towards all of this region, where the same application is applied, where we're looking at vessels, oil spills, and everything in between. I'd like to acknowledge all our partners, and thank you.